going to go ahead and get started. Hello, everyone. Welcome. Sat Sri Akal Saturnu. My name is Baani Behniwal, and I am here on behalf of the Climate Center. We are a nonprofit advocacy organization working to scale up climate action in equitable and science-based manners. And I have the pleasure of being your moderator today. Now, before we hear from our rockstar group of panelists, I do want to set a little bit of context. So, the science is becoming increasingly clear. To reach our Paris commitments, we not only have to phase out fossil fuels and other major sources of greenhouse gases, we have to be actively drawing down existing and excessive carbon from the atmosphere in order to restore a livable climate. And this is estimated to be at the scale of 10 billion metric tons by 2050. And at the same time, we are facing a biodiversity crisis and increasing global instability due to food insecurity and water scarcity. Now, one of the incredible opportunities to chip away at these multiple crises lays beneath the soil, beneath the dirt under our feet. And it's the soils, which is what we'll be talking about today. In fact, soils touch on a multitude of UN work streams and directly affects 7 of the global SDGs, or Sustainable Development Goals. Now, I'm going to quickly list them out because it's important to remind us just how far-ranging the effects of healthy or unhealthy soils are. The SDGs include life on land, responsible consumption and production, sustainable cities and communities, clean water and sanitation, good health and well-being, zero hunger, and of course, climate action. Soils are the largest terrestrial carbon sink on our planet and essential for our food systems. But due to decades of land degradation, soils around the world have been heavily degraded and threaten everything from our ecosystems to our economies. It is without doubt that without healthy soils, we will have trouble with life on Earth. Without healthy soils, there's no future for humanity, not to be overly dramatic. And so to give us an overview, we're going to start off with our first panelist, Dr. Jack Hannam. Now, Dr. Jack Hannam is the president of the British Society of Soil Science, a soil scientist specializing in soil data, digital soil mapping, and soil health. She leads the Land IS team at Cranfield University, which is responsible for the national soil data for England and Wales. She also teaches soil systems at the Agri-Food and Water graduate programs at Cranfield and supervises master's and PhD students. Dr. Jack, over to you.
Great, thanks, Bonnie. Welcome, everybody, and thanks for the introduction, Baani. I'm just going to touch on some of the statistics that Bonnie's already provided with us today. So just to point out that soils are the largest terrestrial stock of carbon. They hold more carbon combined than the plants and the trees that they support, and the crops that they support, and the grassland that they support, and the atmosphere combined. So they are a huge sink, and the carbon in the soils is drawn down from the atmosphere through the plant system. So I'm going to kind of explain how that process works so we get an idea of how we can start to integrate best practice to encourage sequestration of carbon in soils. So what is the potential then, sequestration? So everyone likes a statistic or a number. As you can probably imagine, there's a huge amount of uncertainty in trying to come up with these numbers, and scientists have been arguing over them for many decades. And as Baani pointed out, the reason why we have this potential is because the systems are actually degraded already. So they have historically lost carbon over many years of transforming natural systems into agriculture. And those agricultural practices have further decreased the carbon stocks, particularly in cropland systems. So how much can we actually squeeze into soils then? What is the potential? So here is some numbers. So this kind of additional sequestration is estimated, there are lots of estimates, at between 2 and 5 gigatons of CO2 per year. So just to put that in perspective, if you look at the latest statistics, I think from 2022, the annual emissions from India of CO2, or of greenhouse gas emissions, are around about 2.6 gigatons, and the USA is around about 5 gigatons. So this is the potential that we have in soils. This potential, however, has been estimated from what you could do with absolutely best practice, transforming our systems, transforming them back to nature, transforming farming systems. So probably in reality, this number is a lot lower. Okay, so how does it work? Lots of people talk about this, there's lots of rhetoric. I don't want to stand here and give you a lecture on soil carbon either, but just to give you an idea about how this process works. So what's going on here? Well, how do we, just shovel carbon into the soils? It just doesn't magically appear. So the carbon dioxide is taken in, so that white blob in the middle, by the plants. So the plants and the trees that the soil supports are basically our conduit for that carbon to get into the soils through photosynthesis. So that carbon is taken up into the plant system, so not just the leaves, and we want to kind of look below ground as well. So that's really where those processes are happening. The carbon is stored in both the roots of those plants as well, and there's this brilliant symbiosis between the roots and the microbiology in the soil. So the soils are actually teeming with life. There's about more microorganisms in one little spoonful of soil than there are people on the planet. Unbelievable statistic. But these microbes are really key, actually, to the cycling of carbon in soils. So they have this great relationship with plants. The plants provide them with a little bit of food, they secrete some sugars, and the organisms then actually provide nutrients to that plant. So there's this really nice relationship. We have the plant providing exudates of sugary substances that basically the microbes can use as food source. So we have these inputs, if you like, so from the plant itself, from the leaf litter that we can see, but below ground we have all of these things happening. So the carbon in the roots, those will start to degrade. We have carbon in the microorganisms as well. So think about the number of microorganisms. They're very small, but there are billions and billions of them. They themselves are also a carbon source as well in the soils. So we have this kind of natural cycle, and soils do naturally emit greenhouse gases. We have to hold our hands up. It is a natural process. If any of you make compost, perhaps, you will see this degradation. It's, you see the leaves of the trees, they disappear. So those, eventually, some of that carbon will be processed by those microorganisms and released back into the atmosphere as carbon dioxide. So some of it will actually hang around for a bit longer. So some of what we call necromass, so the dead organisms, the microorganisms, some of those roots as well, will become bound with some of the soil minerals, with clay particles, and actually they become really difficult for those microbes to break down again. And it's this kind of stable and more resistant carbon pool that is really important in terms of sequestration. This is the stuff that hangs around for tens of hundreds of years. So that's that bit at the bottom. We do have a little bit of that carbon pool as well, which we need to be cycling because we want the nutrients to be released from that organic matter, as well as the carbon. So we do want some of that carbon to cycle. It's really important for the plants and the organisms in the soil. So this is the kind of rapidly assimilated. So that's that kind of top pool that we've got. And the reason I've put kind of then those dollar signs against those different pools, well, there's a couple of reasons. So one analogy to get you thinking about how the system works is that fast pool, and I don't want to kind of reveal my spending habits too much, but that fast pool is your current account. your checking account. So your wages come in, you spend it on X, Y, and Z. We won't reveal what that is, but there is a flow of that money in and out of the account, and it's topping up and draining. I don't save an awful lot of my kind of stuff in the current account. So that's that rapid pool, but we need that to survive, to basically live. But the more stable pool is my savings account, where I put stuff away for a rainy day. It might accumulate over a long period of time. I maybe want to use it to give to my children as an inheritance. It may be stuff that I want to do in the near future, saving for a big holiday. So that is your carbon pool. So that is the bit there which is really important for sequestration. And we may touch upon this later, but the dollar signs also indicate a kind of value of that carbon. So thinking about potential private markets that are emerging for soil carbon, you're going to get paid much more for the stuff that you're keeping in the ground for longer. So one thing to highlight is, right, we've got this potential between 2 and 5 gigatons of CO2 per year, but it's not infinite. So a bit like your kind of savings account, if you go back to when banks first started, like physically there was a vault in the bank with a volume. And as soon as that volume was full, that was it. The same with soils. So soils can only store a potential amount of carbon until all those mineral surfaces and things are basically stored with that resistant carbon. And it will change if we change the kind of inputs or management practices. It will come into equilibrium. And this kind of like storage potential takes some time. It doesn't happen overnight, but 10 to 20 years after you change the management practice to enhance carbon sequestration, it will come up to an equilibrium. And it's a bit like a bucket. It's then full. So, you know, the more you add, the more goes into that rapid pool and comes out as carbon dioxide. There is one exception, so we will talk about these very special soils, which are peat soils later, and they can actually accumulate carbon over long periods of time. Okay, so this is the end of the science lesson, but hopefully that's given you a bit of an idea about how the system works. But those 3 things on the left-hand side there, just want you to remember, it is a natural process, this cycling, this sequestration and emitting of CO2. There is a limit to how much we can store. And just to highlight then, you know, we've accelerated this carbon loss, so this emissions over time due to changing land use, land management practices. So how can we then stuff more carbon in the soils? How can we actually do it? So touching on that, we talk about this major driver of the loss is land use change. Well, we change the land use back. I'll talk a little bit about trade-offs in a minute, but, you know, we want to think it was Nature Day yesterday, thinking about nature restoration. Do we return some of those systems to more natural states? So that's one process we can do. Reforestation, for example. Also, what about changing the farming practices? So we can use things. So there's this, the new term is regenerative agriculture. There's been lots of conservation agriculture. But what can we actually do within those agricultural systems? So this is Food and Agriculture Day. So we can change farming practices that have more benefit for soil, and particularly soil carbon. So we can integrate cover crops in cropland, so between your cash crops. These have demonstrated variable benefits for soil carbon, depending on your system and your climate, but they have multiple other benefits. They are really good at reducing soil erosion, so they actually improve the soil health, they improve the soil structure, they actually encourage that microbiome and increase the biodiversity in soils. Other examples are reducing the amount that we're disturbing the soil, so the amount that we're tilling those soils. And in Argentina, there's been a huge movement of farmers called Appraised, and they have completely changed for their 6 major cropping systems to no-till over a period of around about 30 to 40 years. And they have seen then the carbon sequestered in those soils double over that time period. They've also seen benefits to yields. They've been up by 28%. They've also seen soil erosion decreasing by 33%. So clear kind of multiple benefits of increasing carbon and adopting these practices. And another final thing is thinking about our ecosystems that already have large stocks of carbon. These are not our croplands. These are our kind of semi-natural systems, our grasslands, our native forests, and also our peat soils as well. These are really important. They accumulate. Peat soils are basically pretty much organic matter. So it's really important that we make sure that we restore some of these degraded systems. So, for example, in the UK, around about 80% of our peat soils are in a degraded state. So they are actually emitting CO2 instead of sequestering carbon. In 2020, in Scotland, the degraded peat contributed to 15% of Scotland's greenhouse gas emissions, and this is just second to transport in Scotland. So it's really important for those systems where we have large stocks to actually restore those. And then finally, you know, it would be great, wouldn't it? I could just wave my magic wand and do all of those little things on the last slide. But unfortunately, we can't do that. So, you know, what are the big challenges and barriers that we face to doing these sorts of things I suggested on the last slide? You know, land use change is really tricky. So we demand a huge amount from our soils. We want them to grow food. We want them to clean the water. We want them to be a store of cultural heritage. We want them to grow bioenergy crops because we want to reduce fossil fuel usage. But we only have a finite amount of land to do all of these things together. We still need to feed the world's population as well. So in our agricultural systems then, we're looking at those practices that I talked about, so trying to look at farming in different ways. But how do we know this is having a real benefit, both in terms of the amount of carbon that is stored in the soils, but other benefits of soil health? We need systems, so Lee will touch on this later, that can kind of monitor, verify and report those benefits, so we know that the system is actually accumulating carbon and that soil health is improving. And then finally, it's what about the people? This isn't going to happen in a vacuum. We need both land managers, also from the bottom up, they need to be incentivized to change. They have to see the benefit to themselves, to their business, by increasing soil health, increasing the resilience of their system actually to climate change, and thinking about adaptation as well. Thinking about how then we finance this transition. We know that by changing practices, sometimes those yields will go down for those farmers. So how do we bridge that gap? And what other mechanisms are there from, if you like, the top down? What policy incentives can kind of help facilitate that change? Okay, so that's it from me. Hopefully that's a nice introduction. We've got some great case studies next.
I'm ready for a science class.
Yeah. Great. Thank you so much, Jack. That was a great baseline understanding of how soil sequestration works, what the opportunities are, and what the challenges are as well. I especially liked your checking and savings account analogy. I think that was going to stick with the audience for a while. Next, we'll hear from our virtual panelist, Mr. James Cooke, coming to us all the way from Wales. He will explore a couple of case studies that demonstrate the tangible outcomes for carbon mitigation and storage potential on peatlands. James leads the Peatland Soil and Agricultural Land Use Planning team within the Environmental Sustainability Directorate of the Welsh Government. James has led on the development of the National Peatland Action Program since 2019. His wider team covers a range of evidence, policy, and technical advice, including the development of a soil policy statement for Wales and representing soils through the planning systems in developments of national significance and mineral extraction cases. James, over to you.
Wonderful. Good afternoon, everybody, and thank you very much for the kind introduction. Here in Wales, we've established a National Peatland Action Programme. The Welsh Government aims to restore and sustainably manage this vital but degraded wetland habitats with the aim to protect the peat soil and the carbon stocks that are locked in these soils, restore habitats, reduce emissions, and address a number of other functions and services across a range of land management issues. And we'll explore this over the next few minutes. And as Dr. Jack Hannam said, these soils have been heavily modified by forestry agricultural systems to a point where they do need urgent intervention. And as Jack said, these are our savings account. This is 30% of Wales's soil carbon stock is locked in just 4% of its land area. We will remain with just one case study throughout this presentation, which I hope illustrates both the local and the landscape scale outcomes. And this site, sitting on the west of the United Kingdom, demonstrates a range of land uses. In the background, to the left, we have a mix of closed and open commercial forestry. To the right, we have open grassland grazed by sheep, and the two land uses are separated by a fence running vertically through the middle of the site. And in the foreground of the image, you can see a heavily eroded and dry peat bog. This peat bog is 5 meters deep. However, some of those hags, those green islands of peat that you can see on the image, are greater than 1 meter above the surface of that eroded bog, those darker areas you can see. Peat forms at 1 millimeter per year, and you can see across this slide that there's limited vegetation and peat forming species, and all of these brown areas represent continual peat losses and emissions and no peat growth, and therefore no carbon sequestration to this bog. And with a loss of 1 meter of peat, this represents over 1,000 years of carbon accumulation and storage lost to the atmosphere within the last 40 to 50 years, and continual emissions from this peat soil. So what does this mean for the natural environment of the people of Wales? This image represents a high fire risk, with dry peatland and vegetation acting as a significant fuel load. These upland peatlands supply water to millions of homes across England and Wales. A fire on peat within a water catchment risks jeopardising water quality and ultimately the supply to many homes. And the clean-up costs, as well as the environmental damage, would run into many millions of dollars. So for the landscape, tourism, forestry, farming, and the landowner, there's a loss of income, a risk to stock, and a risk to human health. For species, this is a pretty bleak landscape: block forestry, open grassland, and this degraded bog. The peatland habitat is so degraded, it does not support the key mammals, birds, plants, and invertebrate species that we'd normally expect. And in drier months, there's a lack of water for stock. It doesn't provide a regular flow of water into river ecosystems and reservoirs. Water quality is adversely affected, with eroded peat particles entering the water source and requiring cleaning from the supply. And you think of a healthy peat bog as a sponge, then a dry drain bog like this does not store water in wet months. So that water quickly flushes through the system and contributes to flood events, and the flooding of farmland and the flooding of homes. And the date here, summer 2023, clearly shows the water table far below where it should be. In fact, you can't see it at all. When the water table is critical, it needs to be near the surface to store and capture carbon for habitat regeneration and water supply. This is what it should look like. So the next slide, please. And this image of the same site was taken from the opposite side of the valley some 4 months on. It shows the transformation from a degraded bog with limited vegetation and heavily exposed peat soils to a restored and re-wetted bog. You can see the excavators just about in the top right-hand corner of the image. The drone photo demonstrates the carefully placed lines of the contour bunding, these mini dams arranged into cells to hold water, and reprofiling where some of the heavily eroded peat hags have been graded back into the contour lines. Wales's National Restoration Programme put in place a detailed restoration design using drone LiDAR, imagery, surveys, and significant experience from previous restorations of this type. Design is critical for long-term success, and in the long road to rehabilitate this wetland system, restoration is a specialist and technically demanding. So it's vital that this programme contributes to the investment in skills needed across Wales. The water table has been increased over 1 metre, so the eroded channels we saw are now submerged to protect those islands of vegetation and the bare soils. And the original land surface is now gone, and it's now a patchwork of islands in the restoration profile. And for a site and land around it, we have an immediate fire break, helping protect those grasslands and livestock and habitats and carbon. We have access to water for livestock. We have natural water storage areas. We have a rough surface to slow the flow of water across the landscape after heavy rainfall and slowly release it back into the catchments in drier spells. It also lessens the risk to livestock. Emerging evidence suggests that animals are not being trapped in deep drainage channels or gullies and can now transverse the narrow dams and islands. It provides habitat for a range of species which was previously severely degraded. Next slide, please. 11 months on, and this slide was taken in September 2023. We now see recovery of the peatland system and the habitat, and we've been overwhelmed by the rapid recovery response seen across the whole of this site. The bright green vegetation is those vital peat-forming mosses called sphagnum, colonising each of those dam cells we saw on the previous slide, along with plants like bilberry, heather, sedges, cotton grass, and sundew, Wales's only carnivorous plant, all increasing in abundance. The photo is taken in an extremely dry spell, yet as you can see, the water table remains high for the benefits we've mentioned. And this is a testament to the high quality restoration techniques being employed in Wales and developed in partnership between government, its agencies, restoration practitioners, NGOs and landowners. And in the context of climate resilience adaptation, this bog is beginning its rehabilitation journey. And Wales is expected to experience hotter and drier summers and warmer and wetter winters. So in a degraded state, it would continue to waste away, but now it's been in a restored state. It has the potential to recover and function over a longer and changing climatic period. Next slide, please. This slide shows where our site sits within the wider landscape. The image you've seen relate to the very northern green site on this slide. The remaining green sites are those that have been restored to date. The orange sites are those which will be restored within our current work plan, and the red sites are a longer term work plan. But what this really shows is that we're not looking at one particular site in isolation. These are connected habitats and ecosystems across a larger catchment and an agricultural and forestry landscape. We're already seeing Wales's rarest mammal, the dormouse, recolonise one of these green sites that was restored 3 years ago. And it's hoped as the connectivity of this landscape increases, it will lead to sustainable habitats and populations for a range of plants and species, as well as supporting agriculture, forestry, water supplies, decarbonisation and adaptation objectives. In Wales, we have a declared climate and nature emergency, and peatland restoration offers a unique opportunity for high nature, high carbon benefits. And if you'd like to find out more, please search for the National Peatland Action Programme for its website and YouTube videos. Regions 4 has also recently released its yearbook featuring Wales and the National Peatland Action Programme as a case study, and the British Society of Soil Science has a Zoom into Soils webinar on YouTube featuring the programme work. So thank you very much for your time and the opportunity to share this work and highlighting the vital importance and role peatlands have to play in both nature and decarbonisation and adaptation. Thank you.
Alrighty, thank you so much, James. Thank you for sharing the impressive and quite frankly, visually beautiful restoration project, especially demonstrating how carbon and biodiversity benefits are intrinsically linked. So next, we'll pass it along to Dr. Lee Ann Winowicki, who will take us through both the co-benefits of healthy soils as well as the challenges of monitoring, reporting, and verification, also known as MRV. A little bit about Dr. Lee before she jumps in. She is a global research lead for soil and land health at C4ICRAF, based in Nairobi, Kenya. She's a soil scientist, and her research focuses on scaling farmer-centered landscape restoration, understanding drivers of degradation, and quantifying the impacts of land management on soil health. Not just that, she co-founded the Coalition of Action for Soil Health, or CASH, which aims to catalyze investments in soil health for human well-being and climate. She's also a founding board member of the International Union of Agroforestry. Lee, over to you.
Okay, thank you so much for that. So I heard a lot of S words from the previous speakers. Does anyone remember them?
Soil.
Soil, good, that's one. What else? Yes. Jack is so vivid in her language. She said squeezing, shoveling, stuffing carbon into the soil. And then James said that soil, and he was referring to peatlands, can be a sponge. So I just love that imagery. So thank you for that. And I'm going to talk about some of our research at C4ECRAFT, apologies for my voice in advance, about how healthy soils for healthy people, for a healthy planet. And this is because, as Baani illustrated, soil is central to so many of the SDGs, but it's central to providing nutritious food. It's central to ecosystem restoration. I'm coming from Kenya, where we've committed to restore 5.1 million hectares of land, and that's going to happen on farmers' fields with farmers. And of course, we're here at the Climate Change COP because soil is essential for climate change adaptation and mitigation, as well as biodiversity. And as Jack also highlighted, soil has been limited in its ability to provide these ecosystem services because of degradation. We were on a family vacation, and my son took this photo. This is in Zambia. So soil erosion is the most widespread form of degradation. And one of our research focus is to really see how we can improve the prioritization of activities on the ground. And this requires that we need a monitoring system. But landscapes are diverse. So this is, this is Malawi. So looking at how would you sample a diverse landscape? And I think James also highlighted multiple land uses in his photo. So we have really acknowledged that the monitoring framework needs to assess variability. I was taught by a traditional pedologist where you take one soil sample and say, this is the representative soil pedon for this entire landscape. But we absolutely know that this is not the case. We need to assess variability. So one of the tools that we have is the land degradation surveillance framework. It works at multiple scales. And you can see on the left here, it's a landscape scale of 100 square kilometers. Yet, the sampling framework is clustered, so we're sampling clusters and plots across the landscape to get at this variability that James so clearly showed in that one watershed. And then all the action happens at the plot level. So that's where we're taking the soil samples. We're looking at erosion, as I demonstrated. We're looking at biodiversity, macrofauna, microfauna, and all these key drivers of soil health and degradation. So that's land management, right? One of the most powerful things about this network is look at where it's been applied. Now, since Jack has already told us we're in a soil class, we can also be in a statistics class. Do we see any bias in sampling here? Yes. We've been really implementing this a lot in Africa, and this methodology has been applied in over 40 countries across the global tropics. So Jack is going to invite us to the UK and expand the sampling design to the temperate region. But what happens when you start investing in this type of data is you can start comparing and understanding different ecosystems and how land management is influencing these key indicators of soil health, because these data have been collected systematically, consistently across all of these ecosystems. But you must be wondering, how possibly can we analyze all of these samples? Because we know soil analysis is very expensive. This is where innovation comes in, and this is so important when we talk about MRV, when we talk about the carbon markets. We have to embrace and expand innovation to reduce the cost, to really make sure we can assess this variability that I talked about. So at the C4 eCraft Soil and Land Health Laboratory, we use something called soil spectroscopy. It's very simple. We shine a light on soil. And that light happens to be in the near and mid-infrared range. And this has reduced the cost of soil analysis by 90%. So that's $10 per sample, as opposed to over 100. And we have over 200,000 soil samples. So what do we do with these data? So I noticed that Jack did not show any graphs, so I'm going to show some graphs here and go through them slowly. I told you that you can compare ecosystems. So on the y-axis is this some names of LDSF sites. Now remember, each site is 100 square kilometers. On the x-axis is the soil organic carbon content. And what I'm showing is box plots. So the wider the box plot, the more variability. The smaller the box plot, the less variability. So two things are interesting here. One, we have a lot of variability across sites, and these are all rangeland sites. I just focus on one type of land use here, across East and Southern Africa. But do you notice that the sites that have higher carbon, so the boxes more toward the right, those boxes are often bigger. They have more variability. And this is a really interesting trend because we're also seeing that the sites that have lower carbon have less variability. And that is what is so worrying, and that is what I wanted to link to Jack's opening slides, that through unsustainable management practices, we are almost at a tipping point in some of these ecosystems where degradation has been occurring for decades and decades, and we really need to start investing in restoring the vitality of these soil ecosystems. So this is one example. The next is now linking it to land management. So we've been producing maps of soil organic carbon and linking it to what farmers are doing on the ground. So we do this through citizen science. It's called the Regreening app. 270,000 farmers are using this app in Africa. It's free to download on Android. They've geo-referenced their farms. So the green line is a geo-referenced farm, and it's overlaid on two maps, tree cover and soil carbon, 2017, 2021. Everyone says, and I hope we're not all going to disagree here, it takes a long time to increase soil carbon, but actually what we're seeing is that we can increase soil carbon, and it's not taking as long as we thought because these systems really want it. Remember one of the S words? Sponge. The soil wants to have that carbon, and we can see here that in Niger, which has incredibly low carbon, so nothing like what James just showed in the peatlands, where we have 0.2% or 2.7 grams per kilo, we've increased carbon to 3.7. So our maps are accurate. We can detect marginal environments in terms of low carbon, but also even these incremental changes. So I hope this gives you a message of hope that we can increase carbon even in these incredibly dry environments. My last three slides are just to demonstrate some of the multidimensional benefits of when we increase soil health and increase soil carbon in the systems. And I decided to focus on rangelands because I knew the speaker before me was focusing on peatlands. So one of the benefits is, of course, food security. There was a paper out this year by our colleague Johannes Lehmann and his team that actually went through a massive data set to see how increasing soil carbon can influence crop yields. And these were of grain yields, mostly maize, for example, but showing that when you have higher carbon in your soil, you can increase yields. And they even started playing around with some of these threshold ideas of what ideal soil carbon. And remember, this is 2, or he says 20, and what did I show you in Niger? 2. Okay, so putting things in perspective. There's also a paper this last year about the critical role of grasslands. for storing carbon. And so Jack was talking about the decomposition of roots. I actually took this photo with my friend. This is in Kenya. Look how deep these grass roots are in the system, 4 times the depth of above ground. And the beauty of grasses is they have all these annual roots that die every year, just continually stuffing, squeezing, shoveling carbon back into the soil. And so it's really important that we look at all of these ecosystems, grasslands, peatlands, forests, agricultural systems, and restoring them and building the soil ecosystem. And my last example is, I love this paper that just came out, and we're doing some similar research also in grasslands about the link between biodiversity above ground and soil carbon. So just bringing in that aspect of vegetation, biodiversity above ground, and soil carbon. And again, this is in grasslands. So it talked about that there was a positive relationship between above ground biodiversity and soil carbon. So I know there's so much opportunity and so many benefits when we start investing in soil. And so food and nutrition security, also biodiversity. And then the last one is this amazing paper that we just got accepted this year. We've just been building, using the database, the LDSF database I talked about, and linking it to soil hydrologic properties. And so this is now the largest database for Africa. And we've just shared these data with the global data set. And we looked at what are the factors influencing hydraulic soil conductivity, or really how the soil can store water. So if any of you are from Africa, we've just been coming out of a massive drought in East Africa. And so we really rely on soil to hold water. And we found, of course, where the star is in brown for soil, is that soil organic carbon, higher soil organic carbon, also led to increased saturated hydraulic conductivity. So this is really promising, and this is data-driven. This is a way to use data evidence to understand these processes. And so that's my final slide with that. So thank you so much for the opportunity to speak and to really make sure that soil health is on the agenda. Jack was going to mention, I think, that soil health was included in the Emirates Food Systems Declaration. And so we're making progress for getting soil acknowledged. And I hope that you're even more motivated to wave the flag of healthy soils.
Thank you so much, Lee. Pardon me. Thank you so much, Lee. That was a really great example, especially at the end, about the co-benefits that healthy soils brings, especially in terms of adaptation to the climate crises that we're already facing. And last, but definitely not least, our final panelist is going to bring us home and talk about what kind of role governments can play to support scaling up and incentivizing healthy soil practices, and looking at California as a case study. So I'm pleased to introduce you to Secretary Karen Ross. A little bit about Secretary Ross. She was appointed as the Secretary of the Department of Food and Agriculture in California in 2011 by Governor Jerry Brown, and again in 2019 by Governor Gavin Newsom. Secretary Ross grew up on a farm in western Nebraska, where she now owns 800 acres of the family farm, and where her recently retired brother, a fourth-generation farmer, is mentoring a new beginning farmer in growing no-till wheat and feed grains, incorporating cover crops and rotational grazing for beef production, and is a superb example of a leader that walks the talk.
That's
So
my
Secretary
brother.
Ross.
My brother Dan. Thank you for the invitation, and it's going to become very clear to you in about 32 seconds. I am not a scientist, but I believe in science. We cannot build good policy without science to inform it, so I love the presentation so far today. So I'm here to talk specifically about translating this to policy and how do we scale it up. Sound policy is one way. Doing it in a state of California that is the #1 agricultural state for the United States by leaps and bounds, more production than any other state. but in a state that also has the highest population, is very urbanized, and many people are very far removed from farming and farms. There's a lot of skepticism, so having good sound science is really important to informing my colleagues and the legislative body, as well as with our sister agencies. Our sister agency, the California Association of Air Resources Board, is the one that sets a lot of our policy. They have the scientists to do the modeling, and we work very, very closely with them. So I'm going to talk about 3 policy areas that are relatively new to California and the work that we've been doing on climate for about 20 years now. First of all, every 5 years we update our scoping plan. That was required by the Global Warming Solutions Act that was passed by Arnold Schwarzenegger when he was governor, renewed by a little tiny bit when Jerry Brown was governor, and is really the guiding policy for us to get to carbon neutrality by 2045. It's been in the last 5 years that we recognized we cannot achieve carbon neutrality without natural working lands, without that ability to use nature-based solutions to store that carbon. And I would say we have to feed the soil so the soil will feed us. So food security is a given in all that we're going to talk about. In our update of the scoping plan in 2017, it was the first time that we called out as a category for more work, but one that we would invest in, is the role of natural working lands. But we just didn't have the body of that integrated look at this to be able to include that. But in 2022, and was it December, right at the end of last year, we updated the plan, and for the first time, we have a number of nature-based solutions, and the one I'm going to talk about deals with what we have at the Department of Food and Agriculture. And that was setting a goal for what we would invest in for healthy soils, as well as preserving farmland because of studies we've done in California. If we can keep urban sprawl from going out, we reduce vehicle miles traveled, and that becomes very important for being able to strategically keep our most productive soils and keeping them very, very healthy. So for the first time, we have a goal of really investing in climate-smart agricultural practices so that each year we will add 78,000 more acres that are doing either soil health practices, conserving farmland, and increasing organic production, because organic production is based on the health of our soils and the very types of investments that you talked about. I'm excited about that goal, and that goal will only be achievable if we have investment, which underscores the importance of making sure that agriculture is incorporated into financing these transitions. We're asking farmers who are making their living on that land to perhaps take some risks until they see for themselves the evidence that productivity can help. In a state like ours, and I want you to come to bring your model to California, we're very dry. Our hotter, drier future means we have to do all that we can in our soils to improve water holding capacity. It also helps with nutrient cycling, and over time, it will lower inputs, which is another way of getting to a profitable bottom line. So these are important steps that we're taking as long as we have the investment to do it, and so far we have. We are spending just on our Healthy Soils program now $125 million in the last round, and that's helping us achieve a number of projects in all of the diverse settings that we have. The second policy area I wanted to touch on was actually a 2020 executive order by Governor Newsom, where he really called out the importance of the 400 different crops that we grow in California on 2,500 different soil types and a very diverse, very large state of very unusual geographic situations. But what he did was he directed the Department of Food and Agriculture as our role in achieving biodiversity and nature-based solutions to things. One is to work with stakeholders on farmer and rancher-led climate solutions, really engaging farmers and ranchers to know that on the land, they can play an important and a leading role, that we need their intellect, we need their knowledge. And two, he directed us to really look at how do we enhance biodiversity. And for CDFA, our focus was on that at least 25% of the world's biodiversity that is below ground. So it's just this year, a couple of months ago, that we released a below ground biodiversity report. We were inspired by the UN's report 2 years ago. We're very fortunate that Dr. Kate Scow, who was one of the co-authors on that report, led our effort on putting that report together, and we will use that to inform many, many actions in years to come. I believe that this is what's building the confidence of our legislators as well as our sister agencies of what we're doing matters, it's important, and it can lead to solutions. We're not to markets yet, but someday those ecosystem services will be recognized and rewarded. The last policy I want to talk on is one that's new. It was passed a year ago. AB 1757 really calls on the state of California to go beyond the ambitions that we do put into our scoping plan every 5 years, but we want that to be achievable, stretch goals, but achievable. AB 1757 required us to put together an expert technical advisory committee with our colleagues at the Natural Resources Agency to set targets that are very ambitious, and those have just been submitted to the agencies early, probably in the first quarter of 2024. We'll release what those recommendations are, but what that's going to do is create more incentive, hopefully support for financial investments. The last thing I want to talk about today, because I want to get, if there's time for questions, get to that. We are not to the point of the confidence and the certainty that people want for markets or to be a part of, we do a cap and trade system, but to be able to award credits with the rigorous kind of system we go through. So measuring, monitoring, and verifying is our big challenge. And so I'm very excited about, I will go back to Africa because I happen to love Africa, but I would like you to come to California to bring your model. This is going to be the question of the day. This is a way of recognizing public benefit as well as real benefit of the land practices that if we want to continue to restore it, we need to be partners as eaters and consumers with our farmers and ranchers to do that. In our state, with 25 million acres of grasslands and rangelands and 8 million acres of irrigated land, we need all the help that we can get. It's not something that any one of us can do alone, but sessions like this to see what's possible and the enthusiasm for it restores my faith in the future. And I might say, I think it's the most exciting chapter in food production that should, if nothing else, make the next generation very excited to be a part of agriculture and producing the food that nourishes us all. But it all begins with the soil. Thank you.
Great. Thank you so much, Secretary Ross. We now have time for question and answer. So before we put it out to all of the audience, I do have a couple of questions here for our panelists. Secretary Ross, I'm really glad that you spoke about the financial incentives needed for farmers. I'm wondering if each of you could actually speak from your perspectives on what some of the financing options are for farmers beyond government grants.
I think it's really important to get beyond government grants. I think they play a very significant role of those initial transition periods, and part of that is to prove the business case. We fund not only direct incentives to farmers individually, we also fund demonstration projects as a way to bring farmers together to see with their own eyes what's really working or not. We put significant funding into technical assistance, making sure we've got people out there to help them be aware of what the practices are, apply for whatever those might be. But I think the real answer to all of this is the marketplace itself has to reward that these farmers and ranchers are doing more than just the food that we touch and eat. There's all these other huge benefits that come from that. And I think as we watch the world call on corporations, companies, businesses, and especially in the food sector, to report on Scope 3 emissions, there needs to be a sharing of the cost of that, doing the practices through the marketplace itself. I don't want to sound like I think that food should go up, because one of the things we all care about is affordability of food, but there's huge benefit to these practices, and I think that when there are purchasing decisions being made, that's going to be an important part of it. The other thing is to really think about our local food systems. For us, we're using the power of procurement through our farms, through school programs, and making a huge transition to really support those small local farmers so that they have opportunities to make those dollars work in the local community, as well as improving the nutrition for kids and giving those children experiential opportunities about what does it take to grow and prepare food, as well as learn about nature and environment.
Great. Anyone else?
Karen's covered most of it, actually, but yeah, from a UK perspective, there is this little dance at the moment between the public and the private sector. So we are actually in a big reform after coming out of the European Union, unfortunately, where we're developing a new kind of subsidy system where we're actually rewarding for actions rather than the amount of land that you're farming. So this is actually directly rewarding farmers for those environmental benefits. So that's in the public space. But there needs to be a clear blue water between that and access for farmers for private markets, for example, going into carbon credits, for sequestering carbon in soils. And this is, in the UK, emerging. In other countries, they're well ahead. There is some tentative discussion in the farming sector about these markets. They see, obviously, the benefit. Some systems actually are probably, I talked about this saturation of the carbon. So a lot of our grassland systems that are very well managed already are you can't store much more carbon there. So some of our farmers will not have access to those private markets as well. So where can they access that? Because quite often these systems are working in subsistence areas and some of the hilly areas in Wales. So James knows a lot about this. So what are the benefits? So they are providing other types of benefits. So it's looking beyond carbon to biodiversity type financing in the private sector.
Great. And so I'm so inspired by you, Secretary Ross, and how innovative California is. And I think that innovative approach is what is really needed. So I'm based in Kenya, and I think we really need to start rethinking how to incentivize farmers to invest in building healthy soil ecosystems. And I think the business as usual, or even some of the older approaches that have been tried, they're just not working. So I think we really need to collectively rethink about this. I think it's going to need engagement from government, private sector, philanthropy, financing from banks, and within the Coalition of Action for Soil Health, we're partnering with private sector in something called the Soil Investment Hub, and looking at transparent and equitable ways to financially incentivize farmers to invest that will encourage sustainability. And it's really exciting because I think once you start bringing together people from different backgrounds, from different sectors, from different disciplines, including the farmers, the pastoralists, we can really rethink this and redesign together. Kenya's actually hosting the largest soil carbon project in grasslands, 1.9 million acres. That's not 25 million, but still, we're quite excited. And this is a very important project because all eyes are on it. The other projects funded by the World Bank have been in agricultural systems, cereal crops with agroforestry, and this is the first rangeland carbon project. So there's a lot happening, and I think it's going to need collective action.
Certainly a all hands on deck approach. Yes. James, did you want to add anything?
Yes, thank you. Yeah, there's a clear role we see in Wales for government, because government funding needs to act as the foundation stone for peatland restoration. The upfront capital costs are so significant. It's very difficult to be able to find a way to get private finance to put that capital cost in at the start when we're not really sure what the recovery and sequestration rates are going to be, to allow finance to have confidence in that restoration. So we've got this upfront cost where government is involved. We've also got making the markets accessible. We've got providing confidence, data and verification where government has a key role. And then we're working with bodies like the IUCN to look at the peatland code across Wales and the United Kingdom and its application. But with peatlands, because it's such a long rehabilitation exercise, the ongoing sustainable management of peatlands is critical, and we see that as a key area for private markets to help support us on that, running through from now through 2050 and beyond.
That's exactly right. Thank you, James. I want to bring it up to the audience. Do we have any questions there? Do we have a mic?
Thank you, all of you, for the incredible sharing. And I have one question. It's more on the science side. I'm not a soil scientist by training, but I did a little bit of soil science at Yale University. So I wanted to ask, there's the difference between the stable carbon and the labile carbon pool. So I'm glad that Secretary Ross brought up the challenge of MRV. So how much of the current protocols in the voluntary carbon markets actually have that differentiation between the increase in carbon, the differentiation between what's going into the stable pool and what's going into the labile pool? And do you think the difference is significant? Is it a challenge, something that MRV companies and agencies should be paying attention to? Yeah. Thank you.
Yeah, great question, actually. I don't know is the answer whether the carbon markets are doing that. You can measure the different fractions, so that is possible. I assume that they're just looking at the total organic carbon content, so not actually splitting the pools, but I don't know for sure. But that's definitely something when we're looking at kind of guidance for this, is that we start to look at that stable pool. And again, there is always this issue between different types of soil will have a different capacity to store in those different pools as well. So just having one number is quite tricky. So you need to be looking at increasing within that system, so within that particular soil type, within the climatic region that you're in, within the type of land management that you're doing. So yeah, it's a bit like with if you like, a threshold for air quality. There is one threshold for that, for PM10, for example, with clear impacts on human health. For soil carbon, there are different thresholds for different soils, because naturally some soils are better at storing carbon, they have more mineral surfaces, these sorts of things. So it's those sorts of things that need to kind of be taken into account. And this is where Lee's work on like baselining is really important, so you can actually then, and going back and monitoring what's happening over time.
And just to add, it's a really good question. I don't think we need to be too concerned right now. There's some really nice research actually coming out of Germany with Christopher Poplau, and he's been showing, looking at mineral versus particulate matter associated organic material. And turns out most of the ecosystems are not near saturation. Peatlands, some of these really healthy grasslands that you were talking about, Jack, but we still have a huge need and potential to increase the carbon in most of these ecosystems. And our paper is just coming out from the LDSF across Africa, 516 samples, where we did carbon dating, kind of dispelling some of these myths about how quickly we used to think carbon was cycled. And it turns out in some of these systems in topsoil, 500, 1,000 years old. Old carbon, even in these dryland systems, it's very exciting. So I'm not too worried. I hope we have to worry about this, that we put so much carbon in there, we really need to be focusing on that. Thanks.
Yes.
Yes, thank you very much. My name is Ekwe Dosa. I'm the Director of Soil Health at IFDC, the International Fertilizer Development Center. And I'm very appreciative of the great presentations that opening our eyes that soils, by all means, have to be part of a solution to mitigation and reducing climate change impact. And in Africa, in sub-Saharan Africa, where we have farmers are smallholder farmers, and they have to be engaged in the process of increasing carbon in soils. It's an initiative that will require support from the government, because when you invest in soil health, you don't have the results immediately. It's a long-term investment. And for small farmers to be engaged, there will need to be an incentive, a policy that will support such motivation for smallholder farmers. That's, you mentioned that, and it's very important that we keep that in mind. The other thing, soil health, monitoring soil health, as you mentioned, most of the time we focus on the stable pool of carbon in soils, but this has to be ecosystem dependent. In sub-Saharan Africa, we have sandy soils, and sandy soils have weak aggregation and have low potential to sequester, that stable carbon. But it doesn't mean that nothing can be done. We can here still encourage, return of biomass to a soil that will maintain that labile pool. If we replenish it, we encourage people to replenish it on a yearly basis. You measure the stable one, you don't see the difference, but we are doing something in terms of supporting carbon pool in those sandy soils, and that will already be a good contribution to reducing climate change and things like that. So the focus will be on, of course, biomass production, and also replenishment, sustaining yearly replenishment in areas where the soil cannot hold that much of a stable pool. It's not seen, when you measure it, you don't see it, but the impact is really significant. So these are points that I wanted to bring to your attention. Thank you very much.
Yeah, thank you for that contribution. And there's two mics going around, so sorry for that confusion, but next we'll take the question from the gentleman in the black jacket.
Plant scientist and representing the Global Plant Council, which is a coalition of various scientific societies. And my question is, you did mention about the contribution or the positive impact of plant diversity, not only on soil carbon, but also soil carbon nitrogen ratio. Mm-hmm. So what kind of diversity of plants you think contributing to this carbon nitrogen ratio? Is it to do more with leguminous species or kind of diversity? Can you explain a little bit more on this, please?
Great, and I'm sure Jack will help me, and probably James. Actually, one of the things that I think is important for us to think about, and that's why I tried to show some photos of the soil profile, is that soil can be quite deep, and so that plant diversity, we can also think of looking at the roots. So it's really important that we start thinking about exploiting the entire soil profile. So having deep rooting plants like trees. I work at World Agroforestry. And then, having plants that are using different layers of the soil profile. And of course, nitrogen fixation is incredibly useful and important. But that gets to the point of functional traits. So we actually have quite a few publications out now about looking at functional traits. So a functional trait of nitrogen fixation versus, having big leaves or things that relate to the function of the plant. So looking at what is the diversity of these functional traits that's also increasing the ecosystem function in terms of soil carbon. So I think there's many things to look at. And in the grassland species, I'm just putting a call, if there's any donors out there, a real call for action. Again, we're in some of these degraded ecosystems, we're at a tipping point where we're losing so much diversity that, this idea that if you just leave land fallow, everything will come back. We actually need active restoration in some of these dryland, rangeland systems. For example, we have an LDSF site. So how big is it? 100 square kilometers. One site, we have 91 species of perennial grasses. In a neighboring site, 11 perennial grasses. So there we're lacking functional diversity, actual diversity. So I think it's really important that we actively engage in restoration with communities, but also look at the different aspects of diversity. And since you're a climate scientist, I'll also put a plug. One of the things that was really upsetting me in my career is climate models that missed degradation indices. So we have produced global maps of erosion, and we're putting it out every single year since 2017 because we really think that the climate models and crop models, global models, can really benefit and improve and have more sensitivity when they include soil erosion, land degradation, because we know a degraded ecosystem is more vulnerable to climate shifts. And so I think it's really important that we start layering some of these data sets and starting from the soil up.
Great. Does anyone else want to take that question?
I think Lee covered it.
Yeah.
Pretty thorough. Yeah, that's great.
Okay, great. That actually leads me to one more question before we go back to the audience. Something that was brought up very briefly during the presentations was the risk of reversal. So this is kind of what you're talking about, Lee, leaving lands fallowed or, urban development. So from your perspectives, how do we incentivize farmers and landowners to implement practices in the long term to prevent that?
Well, I think our healthy soils is one example of doing that. We also have pollinator habitat, so hedgerows are something that I care deeply about. Pollinators and hedgerows help with all of that. But we also have a very robust program called the Sustainable Ag Land Conservation Program, which provides funding for conservation easements. And we historically have had small amounts of funding for that, and a lot of the funding for farmland preservation has come from voluntary contributions. And because we now recognize this as part of climate strategy, in addition to the tremendous need for us to make sure that we're not robbing future generations of nutrition security. I want to make sure we're growing good, healthy food. So that has become a very important program for us, and it's helping us as part of our Strategic Growth Council to think smarter about land use. And one of our particular challenges right now is because of our water situation. We have depleted underground aquifers, and now we're in a 20-year process of restoring our aquifers. That land that may not be useful for growing crop every year could be very important to recharge groundwater banking, but we also know we don't want it to be bare. So I'm very interested in grasses in particular, or if there's some other crop alternatives to do that. So really working with the farmer to understand that when you have this land as an asset, we're all dependent on how it's cared for. But I also think at the end of the day, keeping farming in families where it's possible, because we have watched investment funds come in and it changes the community, it changes the outlook for making other than, this is probably public, but when it's only about the bottom line, it drives a different ethic. And for me, the land ethic comes from people who value it, who work on it, who care for it, and really do think about making it better for future generations.
Thank you, Secretary. Anyone else?
So sorry, it's a bit heavy on UK examples, but that's where I work. But in terms of incentivizing practices in the long term, so it's linked to this reform of our agricultural subsidy system. So as I mentioned before, so this is public funding from government, basically to reward farmers for environmental benefits. So it's very difficult to kind of measure the action of a farmer on the water quality of a river that their catchment is contributing to at the end of the catchment. So what proportion are they contributing to that water quality? It's impossible to do that. So actually what they're doing then is looking at those sorts of environmental benefits of different practices on the land. So making sure that there's a proportion of land that has green cover all year round. So we can do that through various means, but primarily through cover cropping, reducing soil erosion, all of these types of things. So implementing practices that will reduce erosion, either by planting the cover crops or minimizing the tillage. So this is how, at least they're incentivizing it at the moment. So you're receiving a subsidy, and that is contributing to those benefits. So we then say, okay, how do we know it's not working if we can't apportion that action of the farmer for something that is really a big benefit is then looking at there is a national monitoring program, so for soils in particular and other things, but we're talking about soils here, but you know, they have a monitoring program, but think about the points on Lee's map. You know, you can only sample a certain proportion of the country, and the UK is much, much smaller than most of the countries in Africa. So they are looking at a broad approach of then trying to do monitoring to say, are we moving in, do we have a direction of travel that is positive for soils? And what really needs to happen is more close monitoring on the ground by farmers themselves. So maybe not using a gold standard of stuff that we would do in the lab from a scientific point of view, but can we get proxies of things? We can get them to look at the soil structure. It's quite qualitative. It actually encourages the farmer to look at their soils and actually decide whether there's benefits. You can count things, you can see some organisms in soil, so we have a lot of earthworms in the UK. Brilliant indicator. I mean, people see those as kids, they're playing with them when they're children, but you know, it's these sorts of things, and how can we use that data that we're collecting on the farm, one, to encourage farmers to continue the practice, but to also report back as well. And one final comment is thinking about, you know, making sure that the policy is flexible, that you can change those practices as we begin to learn more what is happening in different systems. UK is small, but we have really diverse soils and diverse agricultural systems. And we know, like this, we have to do a blanket approach with policy and say, right, we know primarily these things kind of work, but really at the local level, it's identifying really what is beneficial for that farmer, and being able to make sure that policy is flexible enough that the farmer can do something that really does make an impact on their farm for their local context. Enough now.
Thank you. Thank you, Jack. And James, if you want to jump in, feel free to. I can't make eye contact with you directly from this angle, so just jump in whenever you want to.
That's absolutely fine. No, thank you. I think it's a great question, and as Secretary Ross and Lee and Jack have all said, it really does come down to the farmer, especially in the UK, because land is private, and we need to bring farmers with us to make sure that we've got that long-term, sustainable, ongoing management. And there's we've tackled it probably in two ways in Wales. Part of that is working with organisations like Cranfield University to understand what we have, where it is, its properties, and then what functions and services are those soils providing. So there's a data issue. There's a communication issue then in getting that across to not just farmers, but ENGOs, other policy teams within government and its agencies. And then there's a knowledge transfer part. So we have a wonderful programme called Farming Connect in Wales, and they've just embarked on a soil carbon project where they're looking at carbon in fields, under hedgerows, in trees, on farms. So farmers can understand exactly what they have and then employ techniques to help maintain and promote that. So the previous question was fantastic because it links to it. So in grasslands, do you need a more diverse sward? And Farmer Connect helps farmers with that. So introducing more legumes to support nitrogen, infiltration, water storage, and carbon organic matter accumulation across the soils. So knowledge transfer is really important, key aspect of any healthy soil for the ongoing sustainable management. And it's a long-term investment. It's a generational investment as well.
Excellent. Thank you, James. Now back over to the audience. Yes, go ahead.
Hi, I was here waiting with the microphone already. My name is Gracie. I work on projects in South America which connect ranchers to the carbon credit market. So we create an ecosystem where we provide green finance, technical assistance, we provide all the MRV, and we try and support them in these transformation of their areas from degraded pasture to recovered pasture, but then also to rotational systems. And because we're in a tropical system, we also have the possibility of the integrated systems with the livestock, the crops, and even the forest component. And there we see just gigantic gains in soil carbon. And here at this COP, it's been really interesting to see such a focus on food systems. I think it's really positive because it opens a really good space for dialogue about this. And I wanted to know if you guys have any insights for me about how far away we are on looking at the carbon balance of food systems and not just the emissions, because we see these numbers like 30%, and that's from farm, but then it also includes all of the logistics often to the destination, and these are really big numbers. But we're not talking about what the farmer is doing in terms of recovering his area and sequestering carbon in soil through good practices. So I wanted to know if you, and I know the challenges are huge, we can't generalize soil carbon, we know that we have to measure this, but I wanted to know if you guys know of any new upcoming ideas, tools, companies, technologies that are working in this direction to help us account more easily for soil carbon.
That sounds like a Jack question.
Yeah, that's a Jack right here. Yeah, I don't know the answer either. So, to be honest, I don't know. Is personally from my point of view, but there are definitely it's more related to. There are a lot of people jumping into this space in terms of offering kind of monitoring, reporting and verification and different technologies and methods. And, you know, Lee mentioned some of those already to enable us to kind of specifically quantify how much carbon is being sequestered. It's not straightforward, as you can probably imagine. There's lots of different ways we can do it. There's different combinations of things that you can use from taking the samples, which is the, you know, large investment that's needed there, but that gives you an accurate idea, to then using those samples to actually build models where you can integrate it with other kind of spatial data from Earth observation, for example. It is a very crowded space at the moment, and again, this is happening globally, so not just in the UK, that there are people then offering these kind of services where they can do that.
So what I think is exciting is that donors are finally willing to invest in the monitoring. The reason why we have been complaining for decades that there is no data is because donors were literally not willing to invest in this. So at C4ECRAF, we always did the monitoring, but we hid it somewhere, right? And that's how we literally have such an enormous database, because we've been boots on the ground for 25 years, collecting the systematic data. But now, there's something called impact monitoring, that all these donors are suddenly realizing, oh my goodness, we really want to tell our board, tell the global community what the impact of their investments what the impact really is on the ground. And I think that's going to really be a game changer in terms of doing the necessary investments in measuring of the different food systems. And one other aspect is the innovations in monitoring. So yes, I presented just one tool, systematic land and soil health measurements, but now we have so much innovation on how we collect data. Assisted citizen science, the Regreening app, is just one tool, but really using and continuing to innovate around how we monitor is going to build these global data sets. One of the cool analysis that we're working at in East Africa is looking at the contribution of the different grasslands and rangelands versus some of the agriculture, agroforestry, and forestry systems in terms of above and below ground carbon. And then the final call to action is really making sure that we are answering these key questions so that the next COP and the next COP, we're not saying we don't have these data, we need to be really looking at how the different regenerative, climate smart, sustainable land management, agroecological practices are influencing these ecosystem services, and it's all of our responsibility to be contributing to those data sets.
Thank you so much, Lee.
I just wanted to add that this is a hugely important area because we all want to get there faster. But the fact is, this is only the second COP that had a Food and Ag Day. Yeah. And we're still trying to get food and ag and farmers put into some of the text. But I think that what we see in recent years, because of all of this good work and understanding the critical need for it, I think we will see not just donors come to this space. I'm from California, where we have a Silicon Valley and we have a Central Valley, not always well connected. Silicon Valley likes to create new shiny objects, but they also are expecting there's going to be a faster and higher return, and ag doesn't necessarily provide that. but we're essential to life. So somewhere, this is going to happen, and I think the fact that we've already seen so much momentum is only going to help it. So what I'm saying is, it's going to happen. I think it will happen faster, but we need to be thoughtful, and we need to avoid anything that, it's overwhelming for farmers how many people come and say, I can do this monitoring for you, or this is the easiest way of doing it. And I worry deeply about greenwashing, which will blow it up for the real work that we know is possible on the land.
Yeah, thank you, Secretary, for pointing that out. And, it seems like with the newest Declaration on Sustainable Agriculture being signed this year, hopefully that will galvanize the political will to increase investments in this sector. And with that, we have time for one, maybe two more questions if they're quick.
Or we can go now.
Go ahead.
I'll build upon two of the previous questions. We talked a lot about carbon, and you had a little arrow with methane emissions as well. And how big of an issue is methane when we talk about carbon sequestration in the soil? And are there, good practices, or what can we do? It's both an action from someone working on climate finance and looking at carbon credits, and an occasional composter as well.
Yeah, I didn't touch on that because it makes it very complicated. But the obvious one is it's thinking about livestock, but from soils themselves, particularly systems like rice. So where you've got submerged systems, there are quite significant. I'm not an expert on rice, but my understanding from the UK, but there are significant emissions from those different types of soils as well. Also, that naturally peatlands do also emit methane. So even those that are being restored, you're storing a significant contribution, but you do also have natural loss of carbon from those systems as methane as well. So those systems are also anaerobic; they're waterlogged.
Okay.
I just do livestock emission reductions, so that's what I focused on, and we've been able to invest over $300 million to help make that happen. But rice. Listen to the soil doctor. The soil doctor over here.
Alrighty, and that's all the time we have for Q&A. And if this is considered a soil class by Professor Jack here, consider this a soil 101. We've covered a lot of ground, and there's a lot more to dive into. But before we close, I did want to acknowledge all the expertise that we have here in the audience as well. So I'm going to kick it back to Jack to share a call for collaboration with you all.
Oh, yeah. Yeah, I just thought it would be really nice, actually, because people kind of go away and say, well, okay, what can I do now? We've just talked about the food and agriculture system is now, in its infancy at COP, but what we're trying to do at the British Society of Soil Science is actually collect some of these really good practices. There are loads of them around, but to demonstrate, not just in terms of sequestration, but in terms of improving soil health, all of those kind of co-benefits. So there are 2 case studies. If you have your own case studies, we really want to hear from you. It would be brilliant to start to put those together, but it's just to kind of galvanize those examples that we can then use in negotiations going forward and say, these are things that people are doing on the ground and they have these quantifiable benefits either to the farmers themselves, to soil health, or to wider kind of ecosystem services and benefits. So yeah, just scan the QR code, have a look at the British Society of Soil Science website, so it's up there, soils.org.uk. So thanks, I'd like to hear from you.
Great. Thank you so much, and thank you all for joining, and happy Food Day.
So inspiring to listen to you. Do you have your card?
Yes.
Oh, yes.
Amazing. So inspiring. Yeah, I know. Very nice to meet you. Nice to meet you.